Hello, AP Chemistry. This is the beginning of Chapter 4 notes, Chapter 4 and 11. We will do parts of both of these chapters together for this next unit. So this introduction should be a lot of review. There is some new information in these notes for today, but the most important thing is vocabulary to review. Make sure you're familiar with that. As we move forward, we will refer back to it throughout the rest of this unit and moving forward. So water is the most common solvent. We called it last year the universal solvent. Many common chemical reactions occur in water or in an aqueous solution. To understand how chemical species interact in a solution, we must first understand water, the universal solvent. So water is an excellent solvent due to its shape, and water is a bent molecule. So remember, you have oxygen and the two hydrogen, and there are two lone pairs on our oxygen, which causes these bonds to move away, giving it a bent shape for the molecule. Because of this, the electrons are not shared evenly, so oxygen is more electronegative, so the electrons in the bond here are going to be pulled more towards oxygen than they would be to the hydrogen. And that gives us a partially positive charge on the hydrogen and a partially negative charge on the oxygen. And again, that has to do with the electronegativity of oxygen. Because it is more electronegative, it's going to pull the electrons closer to it. So the electrons spend more time closer to oxygen than they do to hydrogen. This uneven distribution of the charge being that from the electrons, makes water a polar molecule. So water is held together by covalent bonds. Hydrogen and oxygen, they're both nonmetals, making them have covalent bonds. When water surrounds an ionic crystal, so some metal and nonmetal bonded together, or some polyatomic ions with a metal, the hydrogen end is going to attract to the anion. So that hydrogen end is going to have that partially positive charge, and it's going to attract to the anion, which is the negative ion. And the oxygen end, which is the negative end of water, attracts to the cation, the positive charged ion. And this whole process is called hydration. Hydration is what causes salts to dissolve. So H2O also dissolves a polar covalent substance such as C2H5OH, and we'll talk a little bit more about polar covalent substances in just a moment. So H2O doesn't dissolve nonpolar covalent substances. Remember, we said last year that like dissolves like, and so if water is polar, nonpolar covalent substances, they're not alike. They're not going to dissolve each other. And the difference is in the substance's ability to dissolve due to its interaction with itself and the solvent solution. Sodium chloride is highly soluble, while silver chloride is classified as insoluble. When the hydration attractions are greater, then the crystal lattice structure, the ion-ion interaction, so that's like the positive negative attraction, the compound is soluble. But if the hydration attractions, and remember, hydration attractions is just the water being attracted to the hydrogen end being attracted to the anion, and the oxygen end, the negative end, being attracted to the cation. That's what hydration is. If the hydration is less than the crystal lattice ion-ion attractions, then that compound's going to be insoluble. And so that's why we have silver chloride is an insoluble salt. Also note that particles are charged ions, and they have a full charge rather than a partial charge on the poles of water, of the water molecule. So when we're going to talk about dissolving non-ionic substances, water can dissolve non-ionic substances such as alcohols and sugars, among others. Although alcohols and sugars contain an oxygen-hydrogen bond or a hydroxyl bond, and that is a polar bond. So this whole oxygen-hydrogen bond, when you see that in covalent substances, that is a polar bond, and just as the OH bond is in water. So this polarity makes that water soluble. It makes it soluble in water. So here's ethanol, a very common alcohol. We'll use ethanol in the lab, and here is that OH bond. That this is called a hydroxyl bond. We won't talk a whole lot about that, but as you move forward in chemistry, you'll talk more about hydroxyl bonds there. So here is your ethanol, and the hydration in the action is due to this electrostatic between the oxygen and the hydrogen on the ethanol. And this is what is called a hydrogen bond. We'll talk more about hydrogen bonds later on in the year. Sometimes you will see this electrostatic attraction represented with a dotted line instead of this arrow with a full line, just so you're familiar with that there. And then here are our sugars that I also mentioned are that water can dissolve. We dissolve sugar in water quite regularly for things like Kool-Aid or other sugary liquids, solutions that we typically drink. So deoxyribose sugar, and here we have this hydroxyl on it, and so those hydroxyls allow it to be soluble in water. So fats do not dissolve in water since they are nonpolar. They lack that OH bond that makes like the sugars and the alcohols able to be soluble in water. So remember, like dissolves like, oh, I need to go back. Like dissolves like is a useful guideline, and last year, you know, that's kind of where we rested with like dissolves like. It's a useful guideline for predicting solubility, so we can still use that to predict whether something dissolves or not, but it's not the explanation. So you must address that electrostatic opposites attract. The hydrogen end of water, which is positive, is attracted to the negative ion, or that, I guess that would be ionic, I'm sorry, late here. That electrostatic attraction between the oxygen of the water and the hydrogen on that OH bond. And this is aspects of the solute solvent. So this is what we are referencing that you need to be able to explain. All right, and then 4.2, I'm just really going to get into the vocabulary. Tomorrow we are going to do a demonstration, and then we'll go forward into some more of the stuff that we didn't really talk about last year. But I want to make sure that you see this vocabulary and you're beginning to become familiar with it. So first off, a solute is a substance that is being dissolved, and the solvent is the substance that's doing the dissolving. We talked a lot about that last year. You know, we talked about the Kool-Aid is the solute and the solvent is the water. We also briefly mentioned solutions that can conduct electricity. So electrical conductivity is the ability of a solution to conduct an electric current. And then we talked about that there's electrolytes and there's non-electrolytes. So electrolytes is a solution that contains ions. Those ions are the electrolytes. And because it has those ions, it conducts electrical charge or electrical current. So the positive ions and the negative ions in solution allow the electrical current to flow between. And that's pretty much as far as we got with electrolytes last year. And then as far as non-electrolytes, we just said that it was solutions made of a soluble compound that does not ionize and therefore does not conduct an electrical current. So your covalent compounds that still are soluble but they do not have those ions would be considered non-electrolytes. The one thing that is new that I want to introduce to you today, and like I said, we will do a demo and look a little bit more at this tomorrow, is the difference between strong electrolytes and weak electrolytes. So a strong electrolyte is a highly ionized solution that easily conducts an electrical current. So this solution is time after time after time always going to conduct electricity because there are lots of your ions that are present in the solution, and so it easily conducts electricity. So like if this is our beaker, there's lots of ions there. Where a weak electrolyte is a solution with a few ions that does not conduct a current very well. So there might be a solution that has like a salt here and another salt here, but these haven't completely dissociated. But then you have maybe one of the salts that has. So it is soluble, but it's not, it doesn't dissociate very easily. And we're going to talk a lot more about that tomorrow. But I want to make sure that you're becoming familiar with the strong electrolyte and weak electrolyte information there. So then the last thing that I wanted you guys to talk to you about today is that a solution is a homogeneous mixture where a solute is dissolved in a solvent. Aqueous solutions are solutions where the solvent is water. So like I said, vocabulary is very important if you need to make flashcards or throw them in a Quizlet. That is definitely a good idea to do. And then I have sent you an email, so you got this link for this video, but then also I do want you to read through sections 4.1 and 4.2 in your textbook. Be able to look at some of their diagrams that maybe are a little bit different than the ones I used on the video here, and then also just another time of looking through the information and the vocabulary that I had in this video. Also, it'll take you a little bit further than what I went in this video, which is a great thing to help lead into tomorrow's lesson. Thanks. Have a great day. Bye.